Hi, everyone. We'll just give it another minute here as people log on. Well, it looks like we may have a small group. We'll see. Oh, here's some more folks joining us. So we'll give it another minute or two here. I realize this week is a little lighter than previous weeks in terms of the chapters and also the homework assignment. I hope that's welcome for some of you. That may be why we have lower turnout this week. I think people are past their learning curve a little bit with StatCrunch, hopefully. All right, well, we'll see who else joins us. Looks like we've got about 4 or 5 of us, which is plenty to get started. And if other people join, that's great. So first order of business, can everyone hear me? Awesome. You never know with this technology. Okay, good. Well, that's good. That's a good start. And I know I'm speaking on average that when I say that this week feels lighter, I know many of you may have different circumstances. And so I don't want to make it sound like this is a light week, but in terms of your reading and new concepts, this is a little lighter. I did want to go over a question that's come up a couple times already by email. And if you've already figured this out, great. It doesn't hurt to be reminded how to do this. I think it was in week 1, I made the mistake of telling you not to use the summary feature. Well, this week you're using the summary feature for the stats tabs. And so if you were confused by that, I apologize. Basically, when you use the stat feature and you do any of the things like contingency tables and you use the summary data, it's really using the stats program more like a calculator than a traditional stats program. In a traditional stats program, we would always have our data laid out similar to how it is in the Excel tables that you upload, where there's one record per case and so on. And there's 2 exceptions in StatCrunch. One is the awkward way in which it handles t-tests, where you have to transpose the data to set up separate columns for the variable. I'm not sure why it requires that. StatCrunch is the only program that makes you do that. And I don't know if it's a conceptual thing where they are thinking of it as 2 independent samples or if it's just a quirk of programming. So you will never encounter that need to do that ever again in other stats programs if you continue on in statistics. I will mention, though, the calculator feature is nice that you can do that. You can enter in counts and have it run statistics that way. There are a lot of online stats calculators. I don't know if any of you have stumbled on these, but if you were just to Google chi-square test calculator or 2x2 table calculator, there's a lot of online calculators for doing quick and dirty stats work like that. And actually, you'll find that some of them might be a little easier to use than the way that StatCrunch wants you to enter the data. And I mentioned those partially just as a way to check your work if you ever wanted to see if the way you set it up was correct and you get the same answer using a different interface, different program. you could do that, especially for something like a chi-square test. Other statistics, it might be a little harder to replicate, but chi-square test definitely. It's pretty common to have our data set up that way, where we may have an exposed group and an outcome of interest, and we simply want to calculate, say, a relative risk or an odds ratio, which we don't really get into in this class, but you want to know, like, is the incidence higher in one group versus another, and you want to know if it's statistically significant. And so those little hand calculators are nice for that. There's a nice one called OpenEpi that has all kinds of stats programs that are calculators that I often use when I don't feel like using other software. But there are many out there, and they're pretty reliable. You always have to wonder who did the calculations behind the scenes. So I haven't seen any errors in StatCrunch, so it seems like it's pretty good. Not that I'm doing the math. I've done some of the analysis and compared it to results in other software, and it always gives me the same answers. So that's good news. We wouldn't want to have different versions of the answer. Okay, so just to quickly review, because it comes up a lot in homework 3, and if you haven't started on homework 3, a lot of you have, I think, and also in discussion 3, it asks you to set up a contingency table using counts that are already pre-populated. It's not raw data. So the way you'll do that is you'll do tables contingency with summary. Okay. Now I have a data set in here that I don't want to use. So before I do that, I'm going to create a new. Let me go to data. I'll just give you an example here. So this is from the discussion. Oops, no, that's not what I wanted. I want something else. Okay, we'll do this one. This is from question 4 in your homework. And this is all it really takes to set up a 2x2 table in StatCrunch, where this is question 4 in week 3, and it has actually one treatment where they receive drug X, and then another group where they don't receive drug X, and then the groupings are greater than 8 weeks and less than 8 weeks. I forget what it was now. Physical therapy or something. So the way you set it up is my columns are here, treatment yes, treatment no. And then this third variable really isn't a variable at all. It is simply just the labels for the two groups. Okay, so it almost looks already like a 2x2 table just sitting here in my data set. But obviously it's not going to tell me any statistics looking at it this way. So, but that's something to keep in mind when you're entering the data, is it really is going to look a lot like the table. In fact, you could put the labels over here and then put the columns over here, and it would look exactly like the table. But if I do stat and then I do tables, contingency, oops, stat. It's really touchy, isn't it? Tables, contingency with summary. So like I said, my row is going to be my variable 3, which is just the labels. And then I'm going to do treatment. And then I'll hit not. And it's down here that you can add some additional statistics. So I will add row percents, column percents, all the things that it asks you to do. Percent of total, expected counts, chi-square test, okay? And then I'll compute. And you'll see here, it gives me a 2x2 table with my statistics, my chi-square statistics. And the way you read these tables, you got your row percent, your column percent, percent of totals, and then the final value in each column, or each cell, I should say, is the expected count, which your text goes over. But basically that is if things were proportionate within this population between the two groups, what would you expect to be in those cells? And so it's deviation from expectancy that the chi-square test is based on, which we can see in this case, p-value of 0.0653, so it did not meet our criteria of statistical significance. And it's important to distinguish the null hypothesis in a chi-square test from a t-test. It's the same concept that there is no difference. In this case, the null hypothesis specifically is that there is no association between weeks or the exposure of weeks and treatment. So there's no association. That would be the null hypothesis. And we fail to reject the null hypothesis, so we aren't really seeing a difference here in this particular instance. So this strategy of using the with summary data feature, it comes up, I think, 3 times, twice in the homework main assignment and then once in the discussion. And in the discussion question, the first one asks you to replicate a table that's in your book. And basically what you're going to do is take those cell counts just as like you would in the homework exercise and put those in, doing it the same way, entering columns, rows, and labels. And you really don't need more labels than what I've showed you here. There are ways in which you can further label the data, but this is perfectly adequate to just have your 2 groups like this. All right, so I wanted to make sure you saw that, partially because they said we weren't going to use summary data, and we do. And so I wanted to make sure that that wasn't a stumbling block. Okay. That is all I wanted to say about that one. Oh, other than the fact that there are other questions where you are actually constructing a chi-square test based on the data itself. So if I were to go back to a more traditional data format, such as, let me load just some good old data here. My data. Oh, sure, why not? Okay, so this data, this is more traditional format for having it in this data table. And I can do a little cross tabulation or contingency table with data. And again, so I'm letting it count up the frequencies. I don't already have the frequencies established, which is normally the case. And I might do something like, I think actually one of your questions was, use pot, use marijuana, I assume that means. And then forgot date, which is some sort of proxy measure for dementia. So these are really great variable labels here. Okay, and then I can do row percent, column percent, percent of total, and then hit compute. And you'll notice the output looks exactly the same, but the way this was generated was based on the program itself counting up what's in your data set. So we've got, oh, and I do recommend when you set up tables, whether it's 2x2 or 3x2 or 3x4, conceptually, it makes sense to have your exposure variable on the rows and your outcome, especially if it's dichotomous, like no, yes, as your columns. It does not matter in terms of the statistics that are generated. That includes both the chi-square test and the percentages, but tradition kind of dictates that, and also conceptually, we think about it as exposure with the outcome at the top. Again, it doesn't matter, but especially if you have multiple categories of exposure, it also visually is easier to deal with when you have more rows than you do columns across. So that's another reason to do it that way. But even with a 2x2 table, I would never deduct points, nor would anyone say that there was a problem with it per se, but just when you encounter 2x2 tables in scientific publications, or especially in the public health and medicine literature, you will see it set up that way. But it is arbitrary in terms of the statistics, because really all it's looking at is for differences across the cells, and no matter how you arrange it, it's going to come up with the same answer mathematically. So this is one of the few cases where that's true, where it doesn't matter. A t-test, obviously it matters which you call the factor variable and the response variable. It absolutely matters, but chi-square doesn't matter. Okay, enough about chi-square. I think about ready to ask you guys or see what your questions are. And they can both be from the current homework or from the past, anything that you're still not sure about. Let me see if there's anything else I wanted to review. I think that was the main thing, is that kind of quirky feature. Another quick reminder is that one way to remember what the null hypothesis is, the word null actually has meaning. It's basically, you think of nil or zero, nada, nothing, zero, right? So when the null hypothesis really just means zero. And so when we're looking at a t-test, we're saying that there's no difference in the means is the null hypothesis. For chi-square tests, it's more like no association is the, so that will always be true in our null hypothesis, unless we're doing some very specific, like one-sided test, which we don't normally do, but you might set up a test slightly different. I will also mention that your textbook and this exam coming up, or this quiz 3, goes into non-parametric statistics. And non-parametric statistics is useful when our data doesn't conform to assumptions that we have for our traditional parametric tests. It's not that common to do actual work using those tests, but it's important that you know that they exist, that if your data does not fit with this particular type of the different assumptions regarding maybe a normal distribution or other things that are an assumption. So the reason there are so many statistical tests all named after dead statisticians, most are dead, I think, I don't know. A lot of them are from the past. I don't think any of these are very new. It's not to add confusion, it's just simply to say, okay, this is the appropriate test given the data. And the important lesson there is that we always are just trying to find the right tool for the level of measurement that we have, or the distribution of the data that we have. And that's like 90% of the game in statistics, is picking the right test, picking the right tool for the job. It doesn't have to be super fancy or sophisticated. Statistics is not about making things more complicated. It's a way to basically make some decisions based on the data, whether there's enough evidence to support a claim or not. The whole thing about the null hypothesis, I know, is very counterintuitive. Why would we Why would we set it up that way? The only analogy I can come up with is if you think about like innocent before proven guilty, it's a sort of conservative approach that we have in our justice system. We need enough evidence to indict or to convict. It's a similar thing here. We need enough evidence to say, hey, this isn't likely due to chance. This is probably real. Notice I said probably. We're going to be wrong about 5% of the time, or depending on what p-value we pick. But chances are we're not too far out of the ballpark. Okay, so that's enough of me talking. Questions that you might have. They can be specific or general. And you can raise your hand and speak up, shout. Nothing. That's really good news if there's no questions, I guess.
I actually don't have a question about the work itself, but more so about the assignments. Are you able to work ahead and finish stuff? Because I have 2 jobs and I usually work at like super late at night, and I try to get as much done as possible. Are we able to go ahead?
Yeah, and you may have noticed this in the grade book, but I tend to grade, in bunches. I usually reserve Mondays for grading, so I probably wouldn't give you feedback until, so if you did assignment 4, week 4 assignment, I will probably grade it on Monday, but I could do it before then.
Okay, thank you.
Yeah, and likewise, I mean, I'm happy to answer questions before then too. There's no, yeah, I totally understand that situation. So go for it. I would say though, because of the way the final exam is structured, make sure you're prepared for that. And because you do only have the one chance and it's timed, so you don't want to try to take that too soon. I will be providing a review session, the last live session. I'm not going to present anything real new, but I will kind of go over some of the key concepts. I did a quick review of the exam today in case there were any questions. I think if you've done well on the quizzes and you reviewed your quiz responses, I assume you're able to do. Are you able to see your quizzes?
When you finish them, you're able to see them, yes.
Okay, good.
I haven't gone back, so I don't know if it's still like available after.
Okay. If for some reason they're not, I will, please bring that to my attention so that I can get those back to you. The reason is they're really important for studying for the final, and that pretty much everything that is asked comes from a previous quiz. And that's not 100% true, but some of the concepts about correlation, some of the very early concepts about a sample versus a population, those will be in the final. But I will highlight what I need to highlight on that Wednesday. I won't foreshadow it too much now, but my general message will be is if you've been doing fine on the quizzes, you will do fine on the final. So.
Okay, that's good news.
Yeah, there's not going to be any surprises. And the only thing I would say about that is just it does cover the whole course, so make sure you have access to your old quizzes.
Okay, and then sorry, one last question about the final. Is it all multiple choice, or will we have to create data sets?
It's all multiple choice.
Okay.
Yep. Yes, you will say farewell to StatCrunch.
Yeah. Yeah.
Just when you get to know it, you have to just say goodbye. No, honestly, this is a good way. I was a little skeptical. This is my first class teaching StatCrunch with StatCrunch, And it really, I think, even though it has some buggy, not buggy, but quirky things in it, it's pretty easy to use. And it also gets rid of a lot of extraneous output. Sometimes when you get output from other stats programs, it creates all these things that you didn't ask it for. And then you're in this awkward situation where you're like, I have no idea what this number means. And that doesn't feel good. What I like about StatCrunch is unless you ask for it, it doesn't give it to you.
Yeah, it was pretty easy. And then on some of the stuff that I didn't really quite understand, there's a million other videos of StatCrunch on YouTube.
Yeah, I have yet to post one myself. Part of that. But hey, if I can become a StatCrunch influencer, no, I'm just
kidding. That's the dream for everybody, right?
In some circles, sure. All right. Other comments, feedback. This is, also an opportunity for you to voice any opinions or things about ways to make the course better. But you can also do that offline. Maybe that's less awkward. But feel free to email me with things if you thought we skipped over certain concepts too quickly, or there were things that just didn't click that need reinforcement. But based on your responses and your homework and your quizzes, I'm like, wow, you guys are getting this, or at least well enough to do the quizzes and the big assignments. So that's good news. That's not always the case. So I hope that you're getting enough practice so some of these things, these concepts become more familiar. And that's really part of what it is all about, is okay, you realize you have two categorical variables. You eventually, with practice, will immediately know you need to do a chi-square test. It'll just hit you, when it's appropriate to do a t-test. What we don't really go into depth in this course is regression techniques, and that's a whole, we do touch on it in week 4, and we do cover linear regression. But if you were to go further in statistics, a lot of the things you would do would be building on the regression stuff. Not to say that these other things aren't important, but we've done mostly bivariate analysis, a little bit of multivariate analysis with ANCOVA, and then in linear regression. But if you were to continue in stats, just know that you would do a lot of linear regression and then also logistic regression, which again is the reason why there's another one, is because that is good for modeling dichotomous outcomes, yes, no outcomes. Similar to a chi-square test, but instead of having a single categorical exposure in logistic regression, which we don't cover, you can throw in any kind of variable type into a model. And that's really what's nice about the regression techniques when we get to them, is you can really use any level of measurement in the model as long as they meet assumptions. But you could have a dichotomous categorical indicator variable, you could have ordinal as predictors, and then your outcome should be some sort of continuous or interval measure. Okay, other questions, comments? Oh, I have something. The final project, do not be intimidated by it and do not overthink it. It's pretty straightforward. I wanted to bring that up. There is, let me just see if I can bring this up for you all. And I hope this isn't a surprise to y'all, but in the last week, there is an individual project, and this is individual only in the sense that you have to pick which variables you want to do, but like that's pretty straightforward. Let's see, it's not letting me apply for it. And then let me see if I can share my screen here. Okay, so under week 4, and in the checklist for week 3, I give you a heads up to start working on this, but it's actually housed in week 4. And you'll see it, week 4 independent project assignment, which sounds really ambitious to throw in the 4th week. It's really not that big of a deal. There's a data set, which you're provided with. And what it asks you to do is to basically do a little test run of lots of the different things that we've done so far. It's kind of like a little summary of the different stats that we've done. So you pick a variable and run a frequency distribution, doing a bar graph. So you're going to want to pick some sort of interval or continuous variable for that one. Descriptors of a continuous variable: mean, median, mode, skewness, kurtosis, standard deviation. So again, this would be kind of review of things that we did earlier in the class. Cross tabulation of 2 variables. Again, you're just going to pick 2 categorical variables. In that case, that would be the most appropriate, or the only one that would be appropriate. And then, yeah, and then there's something, the one that might be the trickiest is well, 4 and 5, basically, one asks you to do when there's 2 groups, and question 5 asks you to do when there's more than 2 groups. So basically ANOVA for part 5. And so you'll want to spend a little time with the data set picking variables. But what you choose does not have to be earth-shattering in terms of scientific innovation. You don't have to like find something that's statistically significant. All you need to do is run the test and use a variable that's at the appropriate level of measurement. And then finally, question 6 is do a scatter plot and a correlation for 2 continuous variables. Okay, so you could pick something like age and BMI and run a correlation between those 2. So let me see if I can do a new share here. Gotta go back to StatCrunch. Let me show you what the data looks like real quick. So if I go to data, load, I already downloaded it, so that's why I have it here. It's nice that it keeps it. You don't have to keep running in. Okay, so this is what the data for the final project looks like, and it's kind of interesting data, and you can see that there are lots of things to choose from. So there's age, age at first birth. And these are categorical: race, ethnicity, education, I guess it would be ordinal. And if you're not seeing, this is the way data often works. You get the data and you're like, well, I think I know what this is, because it looks like, I mean, height 67, okay, that must be inches. Weight 145, that must be pounds, not kilos. But it's always a good idea to have a code book with the data. And there is a code book, but it's not actually accessible to you when you're looking at it in StatCrunch. So if you go to the original data and go to independent project data, and it doesn't really instruct you to do this, so I wanted to make sure you know this. Not that it matters that much, because you could always pick variables you did know what they were. But you'll see here, oh, maybe you can't. In this Excel document, looks really familiar, right? StatCrunch looks a lot like Excel. You'll see here the main tab is the data, But then for the background of the study, there's a narrative of where this came from. That's optional. That's nice to know where the data came from. But then more importantly, or just as importantly, there's a code key, which tells you what each variable means. And you could set it up this way, which is a little awkward because it's wide and hard to print, but it's nice because it replicates exactly what's in the data set. But if I look through here, age at time of interview, okay, well, that I would have guessed. Age at birth, I guessed that, right? Race, ethnicity, etc. But what were some of these other ones? It may have not been as obvious. Total pregnancies, tote pregs was the variable name. Again, I might have guessed that, but it's always a good idea to have one of these code books. So if I were to construct a data set, I always create a code book of some sort like this. Again, I usually flip it so that it's in rows. But it's really important because if you're going to share your data with other people who might want to do other analysis, they have to know what the variables mean. And this goes for ones that you originally collected or ones you create as part of the analysis. It's always good practice to label everything as well as you can and to provide a code book. And you'd be surprised, things that you think they're standardized, so like sex, they may have 1 and 2. Sometimes they'll have the number 1 and 0, and you're never sure, is 1 0, is it male, female? Like there's no consensus on how to label these things. And so you could make a big mistake if you didn't know what the code was. So that's why sometimes you'll see categorical variables where they write in the actual word, so having female and male, the words female and male, as opposed to having some sort of code. I'm always reminded of the students who got acceptance letters to Yale, and they were mistakenly sent letters that they got accepted and they didn't get accepted. And I always think, wow, I bet somebody didn't read the code book. 1 meant yes and 0 meant no. Unfortunately, their computers didn't know the difference. Okay, used pot. How often smoked marijuana in the past month? Felt down, level of feeling depressed. Okay, so it's a kind of quick and dirty scale on depression, physical health, mental health. Okay, mental health component score, physical health component score. Okay, so those would all be appropriate fair game measures to use in the analysis for your individual project. I don't care what you choose. It doesn't have to be interesting, like I said, although I hope that you'll pick something that is reasonable to compare. You wouldn't necessarily be interested in, it wouldn't be reasonable to use like study ID number, like that's meaningless. And I'm sure you understand that, but you may as well pick something that's somewhat interesting to make it a little easier to interpret what the result is, especially if you can like anticipate what the association might be. So anyway, this information, which is housed on separate sheets within Excel, doesn't transfer over into StatCrunch when you import it. And it's important to know that because if I had not had this data as the first sheet, StatCrunch would have looked for this first sheet and thought that was the data. So if you're ever importing data into a program, make sure that it's importing the correct sheet from Excel. We've set it up so that you can't make that mistake, but there are other situations where that could happen. Okay, so that's that for the project. It's pretty quick and dirty. It's probably not going to take you as long as even a homework assignment. Shouldn't take you as long unless you have to go back through your notes and remember how to produce a histogram. But by now you should be fluent enough in StatCrunch to be able to generate those things. Okay. So that's all I had for so far. Any other questions? Or, oh, I'm sorry, there's chat. I always forget chat. Let's see if I can see that. Oh, is there a quiz 4, or is it considered part of the? There is a quiz 4. Oh wait, no, sorry. There is not a quiz 4. Simply yes or no question. I messed it up. Sorry. No, there is no quiz 4. If you right, and it's worth more than the quizzes, so because it's more points. But yes, no quiz 4. Oh, and you guys already answered. Okay. Thank you for taking care of that, y'all. Any other questions? Okay, well, if you've secretly been struggling in pain and agony through this course and need some additional help and haven't spoken up yet, there's no time like the present. I don't mean like right now, but I mean like this week. If you would like to set up office hours with me, either at the end of this week or even next week before the exam, doesn't hurt to do it, doesn't hurt to get on the calendar. You can always decide you don't need it. But like I said, the final exam is not going to be a heavy lift. There won't be things you have to figure out how to do. That it's multiple choice. It's all concepts, and it's honestly, a lot of the concepts should be so familiar to you now that you shouldn't have to go back and study everything from the past. Or I should say, you definitely don't need to go back and read everything from the past. But there may be a couple of concepts where you have forgotten and you may need to review some materials, but you would have time during the exam to look through your notes or other things and find those answers. So it should be pretty familiar. And you've seen the questions that appear in the final at some point previously, whether it was in homework or in quizzes, at least conceptually. All right. Any other questions? Well, as always, thank you very much for taking time out of your busy schedules to check in. You guys have been awesome with meeting deadlines. I really appreciate that. It's made my job a lot easier. And also been really great about asking me questions when you need help. And so let's just keep that up to the end, and hopefully everyone will make it through this alive, including me. So have a great rest of your week, and I will talk to you soon. Bye, everybody.
Goodbye. Have a great day.
See you.